Selenium Java real-time interview questions and answers. 1. What is manual testing and when would you choose it over automated testing? Manual testing is a crucial aspect of software quality assurance that involves human testers executing test cases without automated tools. Its significance lies in the human intuition and creativity it brings to the testing process. Here are 3 key points explaining manual testing and its selection over automated testing. 1. Manual testing suits complex scenarios, like exploratory and usability assessments, requiring human judgment and attention to subtleties that automated scripts may miss. 2. Manual testing is beneficial for initial development and changing requirements, allowing fast adaptation and testing of new features. It's also valuable for UI, GUI, and user experience evaluations. 3. When constrained by cost, time, or unstable environments, manual testing is preferable due to the significant setup and maintenance efforts of automated testing. 2. Explain the importance of test cases in manual testing. Test cases are vital in manual testing due to their impact on software quality. They 1. Detect bugs. Systematic steps catch defects, ensuring reliability. 2. Validate requirements. Confirm software meets specs, enhancing user experience. 3. Analyze coverage. Test all scenarios, minimizing overlooked issues. 4. Aid regression testing. Prevent regressions by retesting prior functionalities. 5. Ensure documentation. Clear roadmap for consistent testing and knowledge sharing. 3. What is the difference between primitive data types and reference data types in Java? Primitive data types represent basic values and are built into the language. They include int, float, double, char, boolean, byte, short, and long. Reference data types are used to store references, memory addresses, to objects rather than the actual values. They include classes, interfaces, arrays, enums. 1. Nature and storage. Primitive data types store actual values directly, like integers or characters. Reference data types store references or memory addresses pointing to objects stored on the heap. 2. Size and performance. Primitive types have fixed sizes and are more memory efficient, suitable for basic values. Reference types are larger in size due to the memory address, potentially impacting memory consumption and performance. 3. Default values. Primitive types have default values, 0, 0.0, false, etc., when declared but not initialized. Reference types default to null indicating no valid object reference. 4. Passing to methods. Primitive types are passed by value to methods, creating a copy. Reference types are passed by value too, but the value is the reference itself, not the object. 5. Wrapper classes. Primitive types lack methods and features. Wrapper classes, for example, integer, double. Reference types inherently support methods and properties of the underlying objects. 4. Describe the difference between equals and equals when comparing objects in Java. In Java, the equals operator and the dot equals method are both used to compare objects, but they serve different purposes and have distinct behaviors. 1. Equals operator. The equals operator in Java is primarily used to compare the references of two objects. It checks whether two object references point to the same memory location in the heap. Example: string str1 equals new string hello. String str2 equals new string hello. Boolean result equals str1 equals str2. / this will be false because they are different instances. 2. Equals method. The dot equals method is a method defined in the object class, and it can be overridden by classes to provide a custom comparison of object content. However, many classes, such as string, list, and map, override the dot equals method to compare the actual content or state of the objects. Example: string str1 equals new string hello. String str2 equals new string hello. Boolean result equals str1 dot equals str2. / this will be true because the content of the strings is the same. 5. Explain the 4 main principles of object-oriented programming. The 4 main principles of object-oriented programming, OOP, are often referred to as the 4 pillars of OOP. 1. Encapsulation. Encapsulation refers to the practice of bundling data, attributes, and the methods, functions, that operate on that data into a single unit, called a class. It ensures that the internal workings and state of an object are hidden from the outside world, and can only be accessed through well-defined interfaces. This helps in achieving data security and maintaining a clear separation of concerns. 2. Abstraction. Abstraction involves simplifying complex reality by modeling classes based on the essential attributes and behaviors of real-world entities. It allows you to focus on what an object does rather than how it does it. Abstraction helps in managing complexity, making code more understandable, and facilitating code reusability. 3. Inheritance. Inheritance enables the creation of a new class, subclass or derived class, that inherits properties and behaviors, attributes and methods, from an existing class, superclass or base class. This promotes code reuse and supports the hierarchical organization of classes. Subclasses can extend or modify the behavior of their parent classes, while still inheriting their core functionalities. 4. Polymorphism. Polymorphism allows objects of different classes to be treated as objects of a common superclass. It enables you to write more generic code that can work with a variety of object types, promoting flexibility and extensibility. Polymorphism is often achieved through method overriding, redefining a method in a subclass, and method overloading, defining multiple methods with the same name but different parameters. 6. What is the difference between a set and a list in Java? A set and a list in Java are both types of collections used to store and manage groups of elements. However, they have distinct differences in terms of their characteristics and intended use. 1. Duplication of elements. Set. A set does not allow duplicate elements. It ensures that all elements stored within it are unique. List. A list can contain duplicate elements. Elements are stored in the order they are added, and the same element can appear in the list multiple times. 2. Order of elements. Set. The elements in a set are not guaranteed to be stored in any specific order. There are different implementations of set in Java, for example, hash set, tree set, each with its own ordering characteristics. List. The elements in a list are ordered and maintain the sequence in which they were inserted. You can access elements by their index within the list. 3. Access and retrieval. Set. Elements in a set can be accessed using an iterator or specific search methods. There's no direct index-based access to elements. List. Elements in a list can be accessed using index-based retrieval. You can directly access elements by their position in the list. 4. Performance and use cases. Set. Sets are primarily used when you need to maintain a collection of unique elements, and the order of elements doesn't matter. List. Lists are suitable when you need to store and manage a collection of elements in a specific order, and duplicates may be present. 5. Implementations. Set. Java provides various set implementations such as hash set, unordered, linked hash set, maintains insertion order, and tree set, sorted. List. Java offers different list implementations, including array list, dynamic array, linked list, and vector, similar to array list but thread safe. 7. What is Selenium? Name different components of Selenium. Selenium is an open-source software testing framework primarily used for automating web applications. It allows testers to write scripts in various programming languages to automate the testing of web applications across different browsers and platforms. Selenium provides a suite of tools that help in various aspects of testing, such as functional testing, regression testing, and load testing. 1. Selenium WebDriver. WebDriver is the core component of Selenium, used for automating interactions with web browsers. It provides a programming interface to interact with browsers, simulate user actions, and manipulate web elements on a web page. WebDriver supports various programming languages like Java, Python, C#, etc. 2. Selenium IDE, Integrated Development Environment. Selenium IDE is a record and playback tool that allows testers to create automated test scripts using a graphical user interface. It's a browser extension and is suitable for creating simple scripts quickly. 3. Selenium Grid. Selenium Grid enables parallel test execution across multiple browsers, platforms, and devices. It allows testers to distribute test scripts and run them concurrently on different machines, speeding up the testing process. 4. Selenium Remote Control, RC. Selenium RC was one of the earlier components of Selenium, but it has been largely deprecated in favor of WebDriver. RC allowed testers to control a browser remotely and execute test scripts, but it had limitations in terms of performance and stability compared to WebDriver. 8. How do you handle synchronization issues in Selenium? Handling synchronization issues is a crucial aspect of Selenium test automation to ensure that the interactions between the test script and the web application are smooth and reliable. Synchronization issues can occur when there's a mismatch between the speed at which the test script executes and the responsiveness of the web application. Here's how I would address synchronization issues in Selenium. 1. Implicit waits. Implicit waits instruct Selenium to wait for a certain amount of time before throwing an exception if an element is not immediately available. This can be set globally for the entire WebDriver instance. However, it might lead to unnecessary waiting times in some cases. 2. Explicit waits. Explicit waits are more precise and dynamic. They allow you to specify conditions to wait for before interacting with an element. Commonly used explicit waits include WebDriver wait and expected conditions. This approach helps ensure that the script proceeds only when the desired state is reached. 3. Fluent waits. Fluent waits combine aspects of implicit and explicit waits. They allow you to specify the maximum amount of time to wait for an element to be in the expected state, along with polling intervals for checking the element's availability. 4. Thread.sleep. Although it's generally not recommended due to its static nature, you can use thread.sleep to introduce a fixed delay. However, this can lead to inefficiencies as it waits for a fixed duration, regardless of the actual availability of the element. 9. Describe the concept of XPath and its types. XPath, which stands for XML Path Language, is a querying language used to navigate and select elements within XML documents, HTML documents, and other structured data formats. In the context of software testing, XPath is often employed to locate specific elements or nodes within a web page or XML document for the purpose of validating their presence, attributes, or content. 1. Absolute XPath. Absolute XPath starts from the root of the document and includes the complete path to the target element. It begins with a single / and then lists the hierarchy of elements leading to the desired element. Example of absolute XPath: /HTML/body/div1/div2/form/input3. 2. Relative XPath. Relative XPath, on the other hand, is more versatile and dynamic. It doesn't start from the root. Instead, it starts from a particular node and uses relationships between elements to navigate. This makes it less sensitive to changes in the overall structure of the document, as long as the relationship between elements remains consistent. Example of relative XPath: //form/input@id=username. 10. Explain how you can perform drag and drop using Selenium WebDriver. In this example, 1. Import the necessary WebDriver and Actions classes. 2. Create a WebDriver instance and navigate to the desired web page. 3. Locate the source and target elements using appropriate locators, for example, by.id, by.xpath, etc. 4. Create an instance of the Actions class and chain the actions needed for drag and drop. Click and hold on the source element, move to element to move the mouse over the target element, release to release the source element, build to compile the actions, and perform to execute them. 5. Close the WebDriver instance when done. 11. What is TestNG? How is it different from JUnit? TestNG, Test Next Generation, is a testing framework for Java that is primarily used for unit, integration, and functional testing of software applications. It provides a rich set of features and annotations that allow testers to create and manage test cases effectively. TestNG is particularly popular in the Java ecosystem and is commonly used for test automation. 1. Annotations and flexible configuration. TestNG offers a more extensive set of annotations that allow testers to configure test methods, classes, and suites with greater flexibility. It includes annotations like @BeforeSuite, @AfterSuite, @BeforeTest, @AfterTest, and many more. 2. Parallel execution. TestNG has built-in support for parallel test execution, which allows you to execute test methods and test classes in parallel threads. This can significantly reduce the overall test execution time, improving efficiency. 3. Grouping and dependencies. TestNG allows you to group test methods and classes using user-defined groups. You can also set up dependencies between tests, ensuring that specific tests are executed in a particular order. 4. Test configuration through XML. TestNG uses XML configuration files to define test suites, test classes, and various configurations. This XML configuration provides more control over test execution and is particularly helpful for complex testing scenarios. 5. Parameterized testing. TestNG offers native support for parameterized testing, allowing you to run the same test method with different sets of input data. 6. Data providers. TestNG includes a feature called Data Providers that enables you to supply test data from external sources, such as databases or CSV files, making it easier to perform data-driven testing. 7. Listeners. TestNG provides listeners that allow you to customize test execution and gather information about test events. This can be useful for logging, reporting, and other monitoring purposes. 8. Reporting. While both TestNG and JUnit offer reporting capabilities, TestNG's default reporting is more comprehensive, providing detailed HTML-based reports with insights into passed, failed, and skipped tests. 12. How do you perform parallel test execution using TestNG? To perform parallel test execution using TestNG, a software tester can follow these steps. 1. Configure TestNG XML file. Create a TestNG XML configuration file where you define the test classes and methods you want to execute in parallel. You'll specify the parallel execution mode as well. This can be achieved by using the parallel attribute and setting it to appropriate values like methods, classes, or tests. 2. Grouping test methods. Group the test methods that can be executed in parallel. You can create test groups by annotating test methods with the @test annotation and specifying a group name using the groups attribute. 3. Set parallel execution mode. In the TestNG XML configuration file, set the parallel attribute to specify the level of parallelism you want. For instance, parallel equals methods : run test methods in parallel within a test class. Parallel equals classes : run test classes in parallel. Parallel equals tests : run entire test XML files in parallel. 4. Specify thread count. Optionally, you can set the thread count attribute in the TestNG XML file to define the number of threads that will execute the tests in parallel. In the above example, the test classes test class 1 and test class 2 will be executed in parallel. 5. Run tests. Run the TestNG suite using your preferred test runner or build tool. TestNG will automatically manage the parallel execution of the specified test classes or methods according to your configuration. Remember to design your test cases and classes in a way that allows parallel execution without causing conflicts or resource issues. Ensure your test environment and application are thread safe to avoid unexpected behaviors during parallel testing. 13. What is Cucumber and what is its purpose in automation testing? Cucumber is a widely used open source tool in the field of software testing, particularly in the domain of behavior-driven development, BDD. Its primary purpose is to facilitate collaboration between developers, testers, and non-technical stakeholders by enabling the creation of human-readable, plain text specifications that describe the desired behavior of a software system. 1. Gherkin syntax. Cucumber uses Gherkin syntax, which is a structured language that allows you to write test scenarios in a clear and concise manner. Gherkin scenarios are written in a format of given when-then steps that describe the preconditions, actions, and expected outcomes of a test case. 2. Collaboration. Cucumber fosters collaboration between stakeholders, including testers, developers, product owners, and business analysts. The plain text nature of Gherkin scenarios makes it easier for non-technical team members to understand and contribute to the testing process. 3. Automation integration. While Gherkin scenarios are human-readable, they can be interpreted and executed by Cucumber. Automation engineers can create step definitions, which are code implementations that map Gherkin steps to actual test actions. These step definitions interact with the application under test and perform the necessary actions and verifications. 4. Reusability. The separation of Gherkin scenarios and step definitions allows for reusability. Multiple scenarios can reuse the same step definitions, reducing duplication of code and effort. 5. Reporting. Cucumber provides detailed and readable test reports. These reports include information about the scenarios that passed and failed, along with any associated error messages. This aids in identifying issues and debugging. 6. Cross-functional testing. Cucumber supports testing at different levels, including unit, integration, and acceptance testing. This enables a comprehensive testing approach that covers various aspects of the software. 7. Regression testing. As the software evolves, the Gherkin scenarios can act as living documentation. They ensure that the software's existing functionality remains intact by serving as regression tests. In summary, Cucumber's purpose in automation testing is to bridge the communication gap between technical and non-technical stakeholders, enable the creation of human-readable test scenarios, provide a framework for collaboration, and allow for the automation of those scenarios through step definitions. 14. How do you parameterize a scenario in Cucumber? To parameterize a scenario in Cucumber, you can make use of scenario outline and examples tables. This feature allows you to create a single scenario template and then provide multiple sets of data to be used as input, making your scenarios more versatile and efficient. Here's how you can do it. 1. Write a scenario outline. Define your scenario using the scenario outline keyword. This outlines the basic structure of the scenario and where the parameters will be inserted. 2. Define parameters. Use angle brackets, less than greater than comma to define placeholders for the parameters within the scenario steps. 3. Create an examples table. Below the scenario outline, create an examples section. In this section, you define the various sets of data that will be used to replace the placeholders in the scenario steps. In this example, the username and password placeholders in the scenario steps will be replaced with the values provided in the examples table. Parameterizing scenarios using scenario outline and examples tables in Cucumber helps in creating more maintainable and reusable feature files and promotes efficient testing of various scenarios with different inputs. 15. Explain the Page Object Model (POM) framework and its benefits. The Page Object Model (POM) is a design pattern commonly used in software testing to enhance the maintainability and efficiency of test automation scripts. It helps in creating a structured and modular approach to designing and managing automated test scripts for web applications. The central idea behind POM is to encapsulate the details of the user interface, UI, elements and their interactions within a dedicated class for each web page or component. 1. Modularity. POM promotes the separation of concerns, allowing testers to create individual classes for each page or component. This isolation makes it easier to manage and update tests without affecting the entire test suite. 2. Reusability. By defining page-specific methods and actions within their respective classes, these methods can be reused across multiple test scripts. This reduces redundancy and ensures consistency in test implementations. 3. Enhanced maintenance. When the UI of a web application changes, updates can be made within the relevant page class, minimizing the impact on the rest of the test code. This greatly simplifies maintenance and reduces the time required to update tests after UI changes. 4. Readability. POM improves the readability of test scripts by abstracting away the low-level details of interacting with UI elements. Test cases become more intuitive and easier to understand, even for individuals without a deep technical background. 5. Collaboration. POM encourages collaboration between developers and testers. Developers can work on the underlying application code, while testers focus on creating and maintaining the test automation scripts using the page classes. This separation of roles promotes a more efficient workflow. 6. Cross-functional testing. POM allows testers to create reusable methods for interactions with UI elements, such as clicking buttons, filling forms, or verifying content. These methods can be used to create comprehensive end-to-end test scenarios involving multiple pages and user actions. 7. Ease of debugging. When a test fails, the error can often be pinpointed to a specific page, class, or method. This focused approach to organization aids in quickly identifying and fixing issues. 8. Scalability. As the application grows and more test cases are added, POM prevents test scripts from becoming overly complex. New test scenarios can be developed within the existing framework structure, making the test suite more scalable. 16. What is Agile methodology? Describe its key principles and practices. Agile methodology is a flexible and iterative approach to software development that focuses on delivering value to customers through collaboration, adaptability, and continuous improvement. Its key principles include customer collaboration, responding to change, and delivering functional software in shorter time frames. Agile practices involve 1. Iterative development. Breaking the project into smaller iterations, sprints, for incremental development and frequent releases. 2. Customer involvement. Regular interaction with customers to gather feedback, ensuring the delivered software meets their evolving needs. 3. Cross-functional teams. Multidisciplinary teams including developers, testers, designers, and business representatives for efficient collaboration. 4. Continuous integration. Frequent merging of code changes into a shared repository, followed by automated testing to identify issues early. 5. Prioritized backlog. Maintaining a prioritized list of features and tasks, backlog, that guides development efforts. 6. Adaptive planning. Adjusting project plans based on feedback and changing requirements, fostering flexibility. 7. Short iterations. Time-boxed iterations, usually 1 to 4 weeks, with specific goals, allowing for quick course correction. 8. Daily stand-up meetings. Brief daily meetings to discuss progress, challenges, and plans within the team. 9. Retrospectives. Regular reflections on the team's performance to identify improvements and implement them. 10. Working software focus. Valuing functional software over extensive documentation, ensuring tangible value to users. 11. Continuous testing. Regular and automated testing throughout the development cycle to maintain software quality. 12. Transparent communication. Open and clear communication within the team and with stakeholders to foster understanding and alignment. 17. What is the main goal of C/CD in the context of automation testing, and how does it benefit the testing process? In the context of automation testing, the main goal of continuous integration and continuous deployment, C/CD, is to streamline and enhance the software development and testing life cycle by automating the integration, testing, and deployment processes. C/CD aims to deliver higher quality software at a faster pace while reducing the risks associated with manual interventions and human errors. 1. Goal of C/CD. C/CD aims to automate integration, testing, and deployment processes in software development, delivering higher quality software faster and with reduced risks. 2. Early issue detection. Frequent integration helps identify integration issues, bugs, and conflicts early, saving time and effort in resolving defects. 3. Automated testing. C/CD advocates automated testing for consistent and thorough verification of software functionality, ensuring reliable releases. 4. Continuous feedback. C/CD pipelines offer instant feedback to developers and testers, facilitating prompt issue identification and resolution. 5. Rapid iterations. C/CD supports small, frequent releases, minimizing risk and enabling swift deployment of features and fixes. 6. Reduced manual tasks. Automation of manual tasks decreases errors and frees testers to focus on creating effective test cases. 7. Traceability and reporting. C/CD generates detailed reports, aiding tracking, analysis, compliance, and auditing. 8. Consistency and repeatability. C/CD ensures consistent testing processes across environments, enhancing reliability.